In this chapter, we will be looking at quadratic equations. In this lesson, we're going to look at how to use the quadratic formula to solve quadratic equations.
Okay, hi everybody. So we're going to take another look at solving quadratic equations, but this time instead of just looking at factoring as a means of solving the quadratic equation, what we're going to do is we're going to use the quadratic formula. Okay? Now this is a formula that's been around for a very, very long time. We've known of this, the existence of this formula for a very long time. And what it is, and maybe I'll zoom in on this right here. What this quadratic formula is it is a shortcut way of getting over a sort of a complicated set of operations that you would apply to a quadratic equation here. So this is meant to solve the equation 0 is equal to ax squared plus bx plus c. Okay? And what we notice about the quadratic formula here is what's important are these coefficients, or what we call parameters. The coefficient of the x squared, the coefficient of the x, and then the constant at the end there. And when we plug those into this formula right here, we're able to get the two solutions, remember, because with a quadratic we have the possibility of two solutions here. And where that comes from is this plus or minus that exists just in front of the square root. In fact, it's worth noting that another way of writing this, the quadratic formula could be negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And I'm only bringing this up here because this kind of appeals to that little geek that lives inside of me here. I love the fact that the two solutions to a quadratic are symmetrically located around this central value here, this negative b over 2a. And if I go to the right this amount, go to the left this amount, that's where my two roots are. Okay? And in fact, that when you think about it, and you'll see this later on in this chapter here, this is actually going to be an important part of the quadratic, the graph of the quadratic later on. But anyway, that's beside the point. This is the quadratic equation. And so what we're going to do now is I'm going to just go through some examples with you of how you would use this to solve an equation. Okay, so to start off with, what we're going to do here is I'm going to actually walk through, I'm going to solve this one here by factoring, and then we're going to solve it again, but I'm going to use the quadratic formula. So here, before I do much with it, I got to factor this in order to get the solutions here. And I'm going to do this by guessing and checking because the numbers I'm working with here are pretty simple. I've got a prime number here and a prime number here. So I know that my two factors, my first, okay, remember to get this term right here has got to be 3x and x. And I know that to get 2, it's either going to be 1 and 2 or 2 and 1. Okay, but this is negative, which means that one of these is positive, one of them is negative. And this term right here is positive, so I know that the larger product here is going to be the positive one. Now, if I put 2 here and 1 here, when I multiply that out, I'm going to get positive 3 and positive 2. Well, when I put those together, in fact, I might even just try that. If I put the 2 and the 1 here, positive 3, I'm going to get 3 and 2 here. The larger one's got to be the positive one, so it would have to look like this based on what I've set up thus far. But when I multiply that out, I'm going to get 3 minus 2. That's not the 5x inside here that I want. Because remember, this is the OI, this is the O plus the I, the outer plus the inner product here. So that doesn't work. So I'm going to try that again. But this time what I'll do here is I'll move the 2 over here, and I'll put a 1 here. So when I multiply this out, I'm going to get 6, that's going to be the larger factor, and 1, that'll be the smaller factor. And when you multiply that out here, I'm going to get 6x minus 1x, and that does get me that 5x that I see in the original question here. And so now I've got these two factors multiplied together, and their product is equal to 0. So I know that either 3x minus 1 is 0, or x plus 2 is equal to 0. And this is going to give me enough information to get x. I'm going to bring the 1 over, and then divide by 3. And then over here I'm going to bring the 2 over, and remember, every time you bring something to the other side of the equation, by You can, if it's being added or subtracted here, I'm going to change the sign here. So the two answers that I get by factoring are 1/3, positive 1/3, and -2. Now let's do the same question, but we're going to use the quadratic formula. Now, before I jump into the quadratic formula, remember that the quadratic formula is used to solve equations of this form. So what I want to do to start off with here is I actually want to identify what all those parameters are. So when I compare that to this equation right here, I see that A is going to be 3, B is going to be 5, and C is going to be -2. Okay, so I've got my three pieces here. Now here's my quadratic formula up here. Okay, it's -b plus or minus the square root of b squared minus 4c all over 2a. Well, I know that is going to be, x is going to be negative of the b value, -5, plus or minus the square root of, it's going to be the b value 5, minus 4 times a times c, and this is all going to be over 2 times the a value. Okay, so now I just got to clean this up a little bit. And actually, although this is kind of intimidating looking, once I plug those in, this is just evaluation. I mean, this is stuff that you've been doing for a very long time here. I just got to actually do the arithmetic here. 5 squared is going to be 25. This is 4 times 3 times -2, so it's going to be -24. But with that negative there, it's going to be positive 24 because I'm subtracting a negative. And then down here, this is going to be 6. Okay, well, 25 plus 24, that is 49. Actually, that works out wonderfully because I know the square root of 49. That's 7. Now, I can't go any lower than this. I'm going to have to go horizontally here. Now, this is where this breaks up into two different problems here, or two different expressions. And I hope everybody catches this because I know after having worked with students before that sometimes this idea of plus or minus it's not clear. They look at this as if it's just one little operation here, but it really does mean plus or minus. So let's do the positive first. -5 plus 7, okay, is going to be 2, positive 2, whoops, over 6. -5 minus 7 is going to give us -12 over 6. And now I can simplify both of those. 2 over 6 becomes 1 over 3, and -12 over 6 is -2. And notice that those are the exact same roots that I get when I did factoring. Now let's zoom out here a little bit. Take a look at the amount of work that I had to do for both of those. So the amount of work is lower here when I could factor. So factoring can be quicker. But, this is kind of a big but here, factoring is not always very straightforward. Factoring can sometimes cause a lot of problems, and it can be difficult to find the numbers that work there. Whereas the quadratic formula, yeah, I needed to do a little bit of work to simplify it down. But this is work that you are already really comfortable with, really familiar with. I mean, most of elementary and junior high, you spend multiplying, adding, and subtracting, so there's really nothing new here. It's just the way that we're putting together that makes it unique. But this is a really powerful tool. This will just work to solve quadratic equations. Factoring might not always work. Quadratic formula will work. Now let's take a look at some more examples. Okay, so now let's solve a few questions using the quadratic formula. So again, before I get into the formula itself, what I want to do is identify the pieces here, getting the parameters. And if I don't see a coefficient in front of the x squared, I know that means the a value is 1. The b value is the coefficient of the linear term, so it's going to be -6. And I will pull that negative in. If there's ever a subtraction between, I will pull that in as a negative on that value. And my c value is going to be 7. So now my quadratic formula says that x will be the negative of the b value plus or minus the square root of the b value squared minus 4 times a, which in this case is 1, multiplied by c. And this is all over 2 times the a value. Okay, so that's just me plugging stuff into the quadratic formula. I don't even have to really think about anything at this point here. But now that that's all in, now I've got to start simplifying this. So I've got the negative of a negative that's going to be positive. And then inside the square root here, the radicand of the square root can simplify. Negative 6 squared is positive 36. And now please watch out for that. Please watch out what happens with that negative there. So often people will even do this on their calculators and they won't put the parentheses there. They'll just put negative 6 squared. And then the quadratic formula will sometimes give an error here if you end up with a negative number inside there. And you got to be careful about that. So please watch. You almost just want to do that in your head. You know that when you square a negative, you should be getting a positive there. The calculator, by the way, knows that too. But if you don't tell it correctly what to do, it will do exactly what you tell it to do. So if you tell it to go negative 6 squared, it will square the 6 and then make that negative. It doesn't know what you're intending by that. So please be careful. Now over here, this will be 4 times 1 times 7 is going to be 28, and there's a subtraction in between. Then in the denominator is going to be over 2. And so now I'll simplify the radicand here, and 36 minus 28 is just 8. And now, bear in mind, let's take a quick look over here. Maybe I'll change colors. We want to simplify the radical. And so now what I do with students here is, my method of doing that is to take that radicand there, and I'm going to split that apart into its prime factors. And 8 is going to be 2 multiplied by 2 multiplied by 2. That is as broken down as I can possibly get it. And what a square root does is it takes pairs of factors, and for every pair of factors you have under that radical symbol there, it's going to spit out a single factor. Okay? And so root 8 is going to end up becoming the same as 2 with a square root of 2. So this is going to be 6 plus or minus 2 root 2, all divided by 2. And now what I'm going to do is I'm going to distribute the 2 to both terms here. Now frequently what people do is they do this incorrectly because they just cancel 2's here. They do this operation of canceling. But you can only cancel factors. Unless, of course, you distribute the division through. Just like multiplication, if you had, for example, if you had x multiplied by a plus b, and that is the same as, that's going to be the same as xa plus xb, okay, that works. Same thing if you have a plus b divided by, let's say x, that is the same as a over x plus b over x. Just the same way that multiplication distributes over addition, so does division. And you've probably seen that before, but people get so used to canceling, this idea of canceling, that they end up applying it in situations where it doesn't work. So really what you want to do here is you want to distribute this 2 to both terms. So make this 6 over 2 plus or minus 2 root 2 over 2. And now that can be simplified because 6 divided by 2 is 3. And 2 root 2 over 2, well, these 2's cancel. Now, not the one under the square root. That's not a 2. That is the square root of 2, so that's not going to cancel. But the 2's will. And so I'm left with a result of 3 plus or minus root 2. So that means 3 plus root 2 and 3 minus root 2. Those are both the solutions to this problem. Okay, now let's take a look at this one. So now the first thing I need to do with any quadratic equation, and we saw this in a previous video here, is I need to have it equal to 0. So here, what I'm going to do is I'm going to move the quadratic term over to the right-hand side, mostly because it's negative here. No, I don't want that. I would much rather work with a positive leading coefficient here. Now, because I'm using the quadratic formula, it really doesn't matter whether I leave it on the left-hand side, like if I bring everything over to the left-hand side or bring everything over to the right-hand side. But I still prefer the way this looks right now. I think it looks better with a positive in front. And now I'm going to identify the pieces. So A is 2, B is negative 4, and C is going to be negative 3. And then I plug things in. So it's going to be the negative of the B value, so negative of negative 4, plus or minus the square root of negative 4 squared minus 4 times A times C, and this is all over 2 times the A value. Okay, and now we just evaluate. So the negative of negative 4 is just going to be positive 4 plus or minus the square root of, and like I was telling you before here, I think it would be smarter if you just knew that negative 4 squared is going to be positive 16, and then 4 times 2 is going to be 8 times negative 3 will be negative 24, and that negative is going to make that plus, so plus 24 all over 4. So 4 plus or minus the square root, and now 16 plus 24, what do we got there? That's going to be 40 all over 4. Okay, and now just like I did last time, I'm going to try to simplify that radical a little bit. So just off to the side here, I'm just going to think about what's in that radical. Well, 40 is 2 times 10, so that's going to be, 2 times 2 times 10, 4 times 10. And 10 is going to be 2 times 5. So remember that the square root forces me to take a pair and pull that out. So I can take a 2 out of that radical, and I'm still left with a 2 times 5. I'm still left with that 10 in there. This is all over 4. Now, I can distribute that to both of those terms there. Okay, I could. Just like I did in the previous one, I could do that totally. But this one here is probably going to look better if I leave it together here. And so I'm going to show you another thing that you can do. I'm not going to worry about that root 10 because there's nothing I can do about that root 10. This is a different term altogether. But the coefficients here I can work with. There's a common factor of 2 to them. So I'm going to factor out a common 2 to both of those. And when I do that, that's going to leave me with 2 from the 4 plus or minus root 10. And this is still all going to be over 4. And then the very last thing I can do here is I can cancel factors. So 2 is now a factor of the numerator, and 2 is a factor of 4 in the denominator. And so I can cancel those out. I can't cancel if it's not a factor. So for example, if that 2 wasn't there, I can't cancel with that 2 right there because the 2 here is not a factor of the numerator. Okay, assuming that this 2 in front here doesn't exist. Now, but because it does, though, I can cancel a factor of 2, and that's going to leave me with 2 plus or minus root 10. And I canceled that 2 down here, and 4, when you divide a 2 out of the 4, I get 2 here. And that's probably where I want to leave this answer, 2 plus or minus the square root of 10 over 2. I really can't do anything else to that that'll make it look better. That is as good as that's going to get. Okay, let's have a look at this one. Now this one, everything's already been brought over to the one side of the equation, so it's equal to 0, so I love that. And so now all I'm going to do is identify what my parameters are. And if there's no coefficient in front of the t squared, it's going to be 1. B is going to be the coefficient of the linear term, so it's going to be negative 5. And c is going to be the constant here, which will be 7. And so once again, I'm just going to plug this into my quadratic equation. So x is going to be equal to the negative of the b value, which in this case is negative 5, plus or minus the square root of b squared minus 4 times a times c. That's all over 2 times a. So you just got to get used to doing that, to plugging that in. And now we just evaluate the negative of negative 5, positive 5, plus or minus the square root of, and again, negative 5 squared. I know that that's positive 25. And this is going to be 4 times 1 times 7, so it's going to be 28. So minus 28. And then 2 times 1 is just going to be 2. Still not done with what's under the radical there. So it's going to be 5 plus or minus the square root of, okay, well 25 minus 28 is going to be negative 3 all over 2. Okay, now, that's interesting. That is a really interesting result here. Because think back through what you've been told about radicals. It's very likely you've been told you can't take the square root of a negative. Now, like I got to be honest, yeah, you can. Okay, we can totally take the square root of a negative. It's just that the answer isn't a real number. Okay, it's going to be an imaginary number, or building on that, it'll be a complex number here. Okay, it's got a little bit of a different vocabulary to it. Now, for us, where I'm teaching here, our curriculum is limited to the real numbers here. And I know that some others out there are going to be fairly comfortable working with an imaginary number, and that's fine. But for us right now, we would say that there is no real solution to this problem. Okay? Soon as that is negative there. Now, 0 is okay. Zero is not going to lead to a problem. You can take the square root of 0. It's just if there's a negative in there, that's where we run into problems. And so this is what we would write at this point, no real solution. Okay, now with this one, same as one of the previous questions here. First of all, what I want to do is write this so that it's equal to 0. So I will bring that linear term over and make that 6x squared minus 12x plus 4 equals 0. I like putting that linear term in the middle. Now, actually, before I jump into solving this, I notice that there's a common factor of 2 to all those terms. So what I'm going to do is I'm going to multiply everything through here right now by 1 over 2. And I can do this because it's an equation. So that's going to give me 3x squared minus 6x plus 2. Now, is this absolutely necessary when I'm using the quadratic formula? No, not. But it's going to be easier to work with smaller numbers anyway. So a is equal to 3, b is equal to negative 6. Now, by the way, your b isn't always a negative number. It's just that in every one of these examples it seems to be. And it's only like that to continually emphasize that point about what to do with the negative there. But anyway, so x is equal to the negative of the b value, again that double negative there, multiplied by the square root of, plus or minus the square root of the b value squared minus 4 times a times c all over 2a. Okay, so 6 plus or minus the square root of, 6 squared, so 36, minus, 4 times 3 is 12, times 2 is 24, so minus 24, all over 2 times 3 is 6. So 6 plus or minus, now the square, what's underneath the radical there? That is going to be 12, all over 6. It would be very tempting at this point here to think that you can cancel the 6's from all of these terms. But remember, this is a root 12. It's not 12, so it doesn't actually behave the same. In fact, I'm going to look at 12 over here. 12 is 3 times 4, and 4 is 2 times 2 times 3. So that's, 4 is not 2 times 2 times 3. 4 is 2 times 2, but multiplied by 3 gets you the 12. There's a pair of 2's there that I can pull out. And so this is going to be 6 plus or minus 2 root 3 all over 6. Whoops. Now, instead of distributing, what I'm going to do here, and I'll write this up on this extra line here. In fact, I'm going to just rewrite this thing so you can see it again here. So it'll be 6 plus or minus 2 root 3 over 6. Oh, you can't see that at all. Sorry about that. I will factor out a common 2 out of that numerator. So 3 plus or minus root 3 all over 6. And then I can cancel the factors. Once I factored something out, then I can cancel. And so this will be 3 plus or minus root 3. And when I cancel the common factor of 2 here, I'm left with a 3 in the denominator. That is as far as I can go. I cannot cancel these two 3's. And I cannot cancel like all of the 3's here, particularly because this is not a 3, it's a root 3. It's not the same thing. So that right there is the end of this problem. And I hope that that makes sense. If you're having a hard time wondering why can't you do that, it's because that line there, that division line, implies brackets around the numerator and denominator. And order of operations specifies that you would have to do the addition or the subtraction, what's inside the brackets, before you do the division. So I would be forced to do that addition subtraction. Because I can't do that, I can't actually move on to the divide by 3 that I'm seeing. Okay, and one last problem here. 5x squared equals 7x. Now again, this is not equal to 0. It's a quadratic not equal to 0. So what I've got to do first of all is move the appropriate term over. Now, in this particular case here, notice that I'm missing the constant term. So when I assign values, a is equal to 5, b is equal to negative 7, if the specific term that I'm looking for doesn't show up, that's because it's 0. And so now, when I plug my pieces in, this is going to be the negative of the b value, plus or minus the square root of the b value squared, minus 4 times a, multiplied by c. Now look at that. So this, because of that 0 here, this whole bit here is actually going to become irrelevant. It's just going to become that. All over 2 times the a value. So when I clean this up a little bit, I'm going to get positive 7 plus or minus the square root of 49 over 10. And the square root of 49 is just 7. So this is actually going to work out quite nicely. So to start off with, because of the plus or minus here, I'm going to get 7 plus 7, or 14 over 10. Or 7 minus 7, and I love that even better, 0 over 10. Okay, now I know you'd never write it like that, but I'm going to use this opportunity to simplify both. 14 and 10 both have a common factor of 2, so that becomes 7 over 5. And 0 over 10, well, that's just 0. And so those are my two solutions there, 7/5 and 0. And I hope that makes sense.